Hello world. This channel is created by Arpit D. Srivankar. I welcome all of you to my channel. This will be mind-blowing. The monkey minds. 3, 2, and 1.
Okay, so now entering into biophysics page, we get this type of things. All HH2, HH passive, soma, apical, exon, basilar. If we click all, then we have all the things, RA, CM, passive, extracellular, and HS. Now, what this biophysics page generally indicates us, it is used to insert biophysical properties of membrane and cytoplasma. That is properties like RA, CM. CM is capacitance of membrane, resistance of membrane, ion channels, buffers, pumps. Okay, so we are going to set all these values. Now, first check all have resistance and CM. That is, we are going to check it. Right click on it. Now has HH means HH true. HH true means these are the things which are going to obey HH equations. Okay, so HH means HH true. HH passive, they are passive. No values are changing with respect to time. Passive means passive. We are going to click on passive. Okay, now for soma basic electrical we are not going to change. Default value means no. Now let's specify strategy here. We are on clicking on it, we get all these type of values, all RS, ES, EM. So now let's change the value. Here RS value will be different in your case, but we are going to change it now to the default value is 100, but we are going to set it to 80. So if the default value is 80, now we are going to change it to 100. Okay, 100 RA. RA has been changed, therefore the X has come. Okay, the point should be noted here. Now in case of CM, we are not going to change CM. We are not going to touch or change the values of HH equations. We are going to change the HH value, HH passive value. Okay, just write it here. What I am writing here, that is 1 divided by 5000. Okay, 1 2 3. Okay, enter. So its value has been changed to 0.002. Okay, and the default value is minus 70. Then we are going to place it to minus 65. E pass. Okay, then click on it, enter. This all these things we have to do in biophysics page. Okay, now we are going to save the model. So in order to save the model, we are going to click on file and then save session. I am going to save session on save copy this. Okay, okay, in order to save new file, I am also creating now new file. Then I'm going to third THIRD. Okay, write the name and put the .ses extension .ses. Okay, and then click enter. Okay, save. Hence our model has been saved now. Now if you want to check that it is really saved or not, so I'm going to just file quite. Again I'm going to click on all program, then I'm going to neuron. Where is neuron? I'm putting neuron. Okay, neuron NRN GUI. Okay, now file load session. I saved my file in NRN folder, and in NRN folder I make one folder called it try. Then I'm going to hit enter, and then this is third session, and then load. Now see, this is our topology, subsets, geometry, as we defined all things. This is biophysics page. Okay, now this button continues create. It will continuously update new things. Now what is GUI builder is doing now? GUI builder is in background, it is creating .hoc script for us. We are not writing now HOC script. Okay, it will help us. It will update all the things previously. .hoc extension file. Okay, continuously create means it will continuously update the changes that we are doing, and it will send the message to HOC script. At there it is also going to update the things. So just click on it. Okay, now you know all the things: intro, how to start, how to stop neuron, what is cell builder, and we have completed all these 4 pages. Now how to save a model, this is also completed. Now the cell builder contains all the specifications of a model. That is simple neuron. A simple neuron model's specifications, all this cell builder contains. Now it's time to start giving signals, and we want to see what changes are going to happen on that model. So for that we are going to give signal sources. Okay, here see the signal sources are point process. They are called point processes. In case of signal sources, we will give external current or external voltage, but in biologically we will what we will say, we will take the cell and then we will give current and etc. all the thing. But here virtually we are giving current or synapse, or we can say any signal source. Okay, so for that we are going to select points or point processes. So how can we find point processes in neuron? So for point process we are going to tools. Then there is one option point process, then manager, and then point manager. Okay, so this window will open. Now there are two options: select point process and show. So in select point process we are going to now select alpha synapse. There are all other options are there exp to sync voltage clamp, oscillator clamp, boom boom boom, INT5, but now we are going to select only alpha synapse. Okay, alpha synapse. These now on double clicking, so it will see the two options, shape and parameters. Shape will give us a shape and parameters give its values. Now at this point I want to show you the alpha equation. Okay, where is alpha equation? This is the alpha equation. GS of t. These the channels, they are obeying 1.1 equation. Okay, okay. GS of t 0 for greater than t, less than t activation. Gmax, this where t act is a time of synaptic activation. GS reaches peak value. Gmax at t is equal to tau of s. Okay, I'm going to exit now, and these are the default values of that equation. Gmax, tau s, and es. Okay, coming back to this point process, we are going to change this one set, one set millisecond value. So at 0 we are going to write here value 0.5 and click enter, and then 0.05 at Gmax, 0.05 and click enter. Okay, now we have point process now completed. Now we have to monitor the graph. So for graph, how we can generate a graph? Go to graph, voltage axis. Voltage axis will pop up. Then again go to graph, and there is one shape plot. In shape plot, this window will open. Just right click here and then go to space plot option. Then in space plot option, by selecting just click left click here and drag the line from, again drag the line from here to here. Now see what happened. Just think about it. New graph will come, right? See, new graph here can come now, which is giving red line. Okay, so now what does this shape plot is doing? Space plot, sorry. It shows VM as a function of position along one or more branches of cell. This graph will change throughout the simulation. Displays the VM as a function of space and time. Okay, this is the main function of shape plot. Sorry, space plot. Graph space plot. Okay, space plot. Okay, then now you can close this window. Now we have three windows, 1, 2, 3, and 4. Okay, now we have 3 windows. Now you to speak. All the things are done now. See, we have given signal, we have given graph voltage axis, wise place plot. Now you have to run the model. So let's run our model. Hey, where all this gone? Neuron. Okay, so to run our model, we are going to select tools and then run control. Okay, so run, this window will come. Now just initialize MB and just initialize run. See, action potential curve is generated now. Now we are going to change the value like 1.5 and then run again. See, the graph is changing now. Now if we want to change Gmax, then we are going to change initialize run. Okay, see, boom, action potential generated. 3, 4, again, boom. Now if you want to change, now it's up to you how you are changing, how you are analyzing these action potential curves. Now one thing I want to tell you, that if you want to keep all the lines, just select. How I'm doing this, just right click here and select keep lines option. Okay, now it will contain all the previously stimulated graph lines. Okay, now if I am going to change tau and then I'm again to run it, initialize run. See, again, boom, next, again let's 0.7 initialize and run, boom, again 0.8, 0.1, 0.1 initialize and run, boom. Now I'm going to change tau time, boom 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 boom, initialize and run, boom, change it, light, analyze it. But one thing, what graph is going to say, just grab it. Okay, don't simply just change into the initialization, single step, initialization, point spotted. We are going to change the axis, change dt, then initialize and run. At background, all these processes are done. Thank you everyone for listening me. Hence we implemented first simple, a very basic simple model in neuron software. Thank you. Peace.